You know, iron is one of those things we see everywhere. It builds our entire world, right? Think bridges, skyscrapers, all that heavy machinery. But here's the part that's kind of wild. That exact same element, it's also flowing through your veins right this second, carrying the oxygen that literally keeps you alive. So how? How can one thing be the backbone of industry and the backbone of life?
And that brings us to the big question, the one at the heart of all this. We're always hearing we need more iron. And we know iron is a metal, so why can't you just, I don't know, nibble on a nail if you're feeling a bit deficient? It sounds ridiculous, but the answer is just absolutely fascinating.
So, here's how we're going to break it all down. First, we'll tackle the paradox itself. Then we'll look at the two sides of the coin, iron the builder and iron the life giver. We'll follow its journey from a mine to medicine, and then we'll get into the beautiful chemical dance that makes it all possible.
Okay, let's dive right in. The solution to this paradox, believe it or not, has almost nothing to do with biology. It's all about chemistry. We're talking about the very same atom, Fe, but as you're about to see, it lives in two completely different worlds.
And this, right here, this is the key to the whole thing. If you get this one idea, the entire mystery just unlocks. It's not about what the element is, it's all about how its atoms are put together.
All right, so let's start with the world we all know best. Iron, the builder. You know, the strong, unbending, solid metal that we use to construct, well, just about everything.
Chemically, this is what we're looking at. See that little zero next to the Fe? That's actually super important. It means the atom has a neutral charge. It's perfectly balanced. You can think of it as being chemically, well, content. It's stable. It has no reason to react with anything.
Its atoms are locked into this incredibly tight crystal structure. Now, that's what makes it so strong, right? But it also means it's completely insoluble in water. And for our bodies, which are mostly water, that's a huge problem. It's great for a bridge, but totally useless for our biology.
And get this, to break those bonds, to actually do anything with this metallic iron, you need an industrial blast furnace cranking it over 1,500 degrees Celsius. That is an unbelievable amount of brute force energy.
Now, let's put that in perspective. A blast furnace at 1,500 degrees versus our bodies just humming along at a comfortable 37 degrees. We use delicate acids and enzymes, not industrial forges. It's not even a fair fight. Our stomachs just don't stand a chance against a chunk of metal.
So, the best way to think about it is this. From your body's perspective, swallowing a piece of pure iron is exactly the same as swallowing a rock. Seriously, your body has no way to break it down, no way to absorb it. It just passes right on through. Completely useless.
So that brings us to the other side of this whole paradox. If we can't digest metal, then what on earth is the iron that we get from things like spinach or red meat? Well, let's step into that other world. Iron, the life giver. The form that is absolutely essential for us to survive.
The iron we can actually eat is chemically different, and you can see it right here. See those little plus signs? That means this is ionic iron. It has a positive charge. And unlike the stable, neutral metal, these atoms are, well, they're chemically restless. They're actively looking to connect with other molecules, and that makes them reactive and available for our bodies to actually grab onto and use.
And this chart really just lays it all out perfectly. You've got metallic iron on one side, a solid metal made for stability with super low reactivity. Then on the other, you have ionic iron, a soluble ion built for biological flexibility with high reactivity. One builds our structures and the other builds, well, us. That's the whole story right there.
So this leads to the next big question, right? If the iron in our supplements and food is so different from raw metal, what does it even come from? This is where things get really cool. It's like a little bit of modern alchemy.
So let's trace the journey. It all starts as iron ore, dug out of the earth. That ore is then refined into the stable metallic iron we've been talking about. But then, there's a crucial third step. Through another chemical process, that metal is completely converted, changing its entire chemical state into something new.
And what you end up with is this, an iron salt. So when you take an iron supplement, you are not swallowing powdered metal, not at all. You're taking a compound, like ferrous sulfate. The iron atom is still in there, sure, but its chemical bonds, its whole environment, has been totally re-engineered to make it soluble and ready for your body to absorb.
But why? Why does our body go to all this trouble? Why does it demand this one specific form of iron and completely reject the other? Well, it all comes down to the #1 job that iron has to do once it's inside of us.
Now, technically, that job is called redox cycling. But honestly, a much better way to think of it is like a chemical dance. This ionic iron is flexible. It can easily grab an oxygen molecule in your lungs and then, just as easily, let it go in a muscle that needs it. It's this beautiful, constant back and forth that makes oxygen transport even possible.
And I love this analogy. The ionic iron is the life of the party. It can do the chemical dance. But metallic iron, it's the wallflower. It's just too stable, too rigid. It can't participate in that vital exchange at all.
And really, it's as simple as that. Our bodies are an incredibly delicate, water-based system that runs on gentle reactions. That's the chemistry of life. It's not the chemistry of metallurgy, which is all about brute force and extreme temperatures. Two completely different worlds.
So, when you boil it all down, that's what we have. One single element, iron, but with two totally different destinies. And those destinies are decided entirely by its chemical form.
I think this says it best. The stable, metallic form of iron builds our world. But it's the flexible, ionic form that allows us to actually live in it. It's just the perfect summary of this whole amazing paradox.
So in the end, an element's identity is about so much more than just its name. It's about its chemistry. And that kind of leaves you wondering, doesn't it? What other common elements out there are living these incredible double lives right under our noses?